This is Doug Ramsey. I'm a professor in the Department of Wildland Resources at Utah State University. This is part 2 of a 3-part set of instructional videos dealing with the U.S. Geological Survey Landsat Analysis Ready data product. Here, I will cover the individual data products and their organization. From the first video, we learned that the ARD product utilizes the best available Landsat 4 through 8 imagery from 1982 to the present and reorganizes the standard WRS path row image frames into a grid system to take better advantage of the overlap between east-west adjacent images. With imagery collected from every Landsat 4 through 8 platform since 1982 that intersects a specific tile grid, a temporal stack can be populated with a large number of images. The H7V10 tile used in this tutorial consists of 3,527 individual Collection 1 Level 1 images spanning 1982 through 2020. For each of the 3,527 acquisition dates in our example, there are 5 different products with associated metadata and supporting ancillary and quality assurance layers. USGS has not only provided the final image products, but also the supporting ancillary data layers used to generate each final image. This is done for data transparency purposes and also to allow users to better evaluate data quality. 2 of the 5 products include Collection 1 Level 1, Landsat imagery converted to top of atmosphere reflectance and surface reflectance. 2 other products are thermal bands, standardized and converted to brightness temperature, as well as surface temperature. The 5th product is a quality assurance bundle of images, each of which are included in each of the 4 reflectance and thermal products. So the quality assurance layers are also distributed across each individual product. If you were to download all 5 products for all 3,527 acquisition dates in our example, the total number of data products would be 17,630, consisting of approximately 143,000 individual data and ancillary files. Seems a bit daunting. But the data are packaged so that the user can download the product that best services the remote sensing problem at hand. The data products are the same across all Landsat 4 through 8 platforms. However, the supporting quality assurance and ancillary data layers vary slightly between Landsat 4 through 7 and Landsat 8 due to the spectral difference between the 2 sensors. An example set of image products from the H7V10 tile dataset. Of the 4 primary products, the top of atmosphere reflectance image is not atmospherically corrected, but pixels are converted to reflectance using per pixel sensor in solar zenith and azimuth angles. The surface reflectance product is processed identically to the top of atmosphere product, but is also corrected for atmospheric attenuation and therefore represents the best approximation of surface reflectance. The brightness temperature product consists of radiance calculated at sensor and is not atmospherically corrected. And the surface temperature estimates temperature at the ground surface and is atmospherically corrected. Pixels are recorded in degrees Kelvin, and as of this date, these data are conditional. Of the ancillary data products, there are solar zenith, solar azimuth, sensor zenith, and sensor azimuth layers identified for each pixel. There is a layer that identifies pixel lineage. This layer identifies from which image the pixel was collected from and essentially represents 1 to 3 images, possible images, on the north-south track of the path, of the orbital path. The pixel quality layer is a bit-packed representation of whether a specific pixel is identified as a fill, clear, water, shadow, cloud shadow, snow, cloud confidence, or terrain inclusion pixel. The radiometric saturation is also a bit-packed representation that identifies whether a specific spectral band was saturated during data acquisition. The aerosol quality layer is included with the surface reflectance product and is also bit-packed representing surface factors that may have influenced the calculation of aerosol influence on spectral reflectance. The thermal products come with a suite of ancillary data layers. They include the upwelling radiance, the downwelling radiance or downwell gradients, the thermal band converter to radiance, surface temperature quality assurance, emissivity estimated from the ASTER GED data, emissivity standard deviation, pixel distance to cloud, and atmospheric transmittance. To better understand the quality assurance layers, we need to know how the pixel values are bit-packed. The bit packing format is defined in the Landsat ARD data format control book. However, I will describe the bit packing strategy for the pixel quality assurance layer for the purposes of this tutorial. Bit packing in this context is a data compression technique that utilizes individual bits within a 16-bit string to store multiple layers of information as binary yes or no responses. For instance, is pixel A classified as cloud? Yes or no. Is it water? Yes or no, etc. In this way, what would typically require multiple layers, multiple rasters, to convey pixel quality data can be done with a single layer. The Landsat 8 pixel quality assurance band utilizes 11 of 16 bits to convey pixel quality data. Bits are written from right to left, where bit 0 is the fill pixel or the fill bit and identifies whether the pixel is a no data pixel. Bit 1 identifies whether the pixel is clear or not. Bit 2 identifies water, yes or no. Bit 3 identifies cloud shadow, yes or no. Bit 4 identifies snow. Bit 5 identifies cloud. Bit 6 and 7 consist of 4 categories. They're combined for cloud confidence. The confidence categories are none, low, medium, and high, and the bit equivalents are 00 for none, 01 for low, 10 for medium, and 11 for high. Bits 8 and 9 are also combined into the same 4 confidence categories, but for cirrus clouds. Bit 10 is a terrain inclusion bit, and bits 11 through 15 are unused. In this example, bits 1, 7, 8, and 9 are turned on, indicating a clear pixel, but with medium confidence of cloud and high confidence of cirrus cloud. Converting this bit combination to an integer would equal 898. These integer values are what you typically see inside the image if you query it with image processing software using a cursor. And of course, there are logically a limited set of bit combinations and therefore a limited set of integer pixel values for these layers. These two tables list the common bit combinations for their integer equivalents and their integer equivalents for Landsats 4 through 7 and Landsat 8. The combinations are different between sensors due to the absence of the cirrus band in Landsats 4 through 7. This concludes the second of 3 video tutorials on the Landsat ARD product.